part of your module 1 where we started with cylinders. So initially we had done problems on cylinders using equations that we have studied in your mechanics of materials. Hope you remember that. Okay. So what is the equation? Lamè's equation. Okay. So using Lamè's equation, we have done few problems. In continuation with that, we will take up compound cylinders problems, right? So problems in the sense, let us understand what is compound cylinder. Basically, in compound cylindrical shell, what will happen is the outer cylinder is having inside diameter smaller than the outside diameter of the inner cylinder. So you will have two cylinders basically. Okay, so you will have two cylinders. I'll take up this way. I'll take up 1 second. I'll new PowerPoint presentation. Okay. Just hold on. Go to window. Yeah. Can you see the screen now? White screen? Okay. Are you seeing the screen?
Yes, sir. Yes.
Okay. So basically, how a compound cylinder is made of is, so this is outer cylinder. Okay. This is the outer cylinder. Then you will have inner cylinder. So maybe something like this. This is inner cylinder. Okay, so this is the axis. Okay, so this is, I would say, inner cylinder. This is outer cylinder. So this is how a compound cylinder is made of. Okay. So basically, why compound cylinder comes into picture is that to withhold the very high internal fluid pressures, a compound cylinder is made. So how it is made? So this, as I said, this is outer cylinder, and this is the inner cylinder. That is, this is inner cylinder. Okay, inner cylinder. So what I was telling is the outer cylinder, okay, will have the outer cylinder before assembly will have inside diameter, that is inside diameter of outside cylinder will be smaller than the inside diameter of outer cylinder will be smaller than the outside diameter of inner cylinder. Okay, so this is one cylinder, this is the outer cylinder. So the inner diameter of outer cylinder will be initially smaller than the outer diameter of the inner cylinder. Okay, then what they do is they will heat the outer cylinder and then shrink fit on over the inner cylinder by heating and cooling. That is basically, are you able to follow me? So that is basically, you have a cylinder, this we call it as inner cylinder. Okay, are you there? Are you there with me? How it is manufactured? Then what they do is they take a cylinder, outer cylinder, this is outer cylinder, okay, whose inner diameter, okay, this is the inner diameter of outer cylinder will be smaller than outer diameter of inner cylinder. Then how this will fit into this is they will heat this outer cylinder and then shrink fit onto inner cylinder like this. Then what you are going to get is a compound cylinder. Are you there? Are you there? Could you understand how compound cylinder is produced? Could you understand?
Yes, sir.
So in such case, what will happen is that you will have the, you will have the stress here. Okay. So the stresses will be tangential stress at inner surface of inner cylinder. So there you will have stress because of fluid pressure. Then tangential stress at outer surface of inner cylinder, that is at this junction, for that is tangential stress at outer surface of inner cylinder is this junction. Then you will have tangential stress at inner surface of outer cylinder, then tangential stress at outer surface of outer cylinder. Okay, so these are the stresses that will act, and then you are going to find out shrink fit also, shrink fit and what is the inference. So this is what we do, and where do we expect maximum stress to be in this assembly? Where is the maximum stress that you can expect? You can expect at the junction of outer diameter of inner cylinder and inner diameter of outer cylinder. We are going to have maximum stress, that is because of shrink fit. Are you there with me? Are you there?
Yes, sir.
Okay. Now, what I'll do, just 1 second. Okay. Um, Break mass center, discover. I'll just show you how the shrink fit is done. Is basic cost of model fit. Okay. Are you able to see the video?
No, sir.
Sir.
1 second. I'll share the video. So I have to stop this and then go for a window. Okay. And yeah, and here I have to. Are you able to see the video now?
No, sir.
Not able to see the video. You can share the. Can you see the window now with these some videos?
Yes, sir.
Okay. Now how do I do this? Now play. Oh, inside. Now is the video visible for you?
No, sir.
No. Okay. How do I do this? Hmm. Now can you see the video? Is the video visible for you?
So the screen is blank.
Screen is blank. Okay. They are not able to see the video.
No, sir.
I think it is not possible. Because how do I share these videos? Otherwise, without seeing that, it is difficult. Okay, anyway. So interference fit is what we discussed about. Okay, and then go to cylinders chapter now. You take out your data handbook, go to cylinders chapter. Go to cylinders. I'll just let you know the page number. Go to chapter 7 where cylinders are there. No, cylinders, pipes and tubes. Cylinders, pipes and tubes. Are you there? Cylinders, cylinder, pipes and tubes.
Yes, sir.
You are in that chapter, no? Okay, there you go to equations 7.35, 35, 36, 37, where it will read as sigma, that is a press and shrink fits heading. Heading of press and shrink fits. You have tangential stress at inner surface of inner cylinder. So it will be represented as sigma T at I. So you have equation there. It's sigma underscore T. So you can add one more, inner surface of inner cylinder. Okay. Do you have the equation there in the form of minus 2pc in the form of minus 2pc into dc square? Is that okay? Divided by dc square minus di square. Are you there? Are you there? Could you get this equation?
Yes, sir.
Yes, sir.
Yes, sir.
This indicates that it is the tangential stress at inner surface of inner cylinder. So that is given by equation 7.35. Next we have got tangential stress at, that is sigma T, tangential stress at outer surface of inner cylinder. That is the next equation that you have got there. Okay, please check. It is given by minus PC, okay, that is pressure, into DC square, that's common diameter, DC square minus DI square divided by DC square minus, what it is there, DC square minus, this is plus here and this is
Di square.
di square, okay, minus mu. Okay, this is the equation for tangential stress at outer surface of inner cylinder. Then you have got the tangential stress at inner surface of outer cylinder. Then similarly you have got tangential stress at outer surface of outer cylinder. These are the 4 equations that are given. Is that okay? Are you there? So it is going to be 2pc dc squared by do square minus di square, d e square, c square rather, dc square. Is that okay? Are you there? So what you can do is, if you have notebook with you, please note down. Please note down. Do you have notebook with you?
Yes, sir. Yes.
Yeah, please note down now. In compound cylindrical shell, in compound cylindrical shell, in compound cylindrical shell, that outer cylinder is having, the outer cylinder is having, the outer cylinder is having inside diameter smaller than the outside diameter of, smaller than the outside diameter of smaller than the outside diameter of the inner cylinder, full stop, full stop. The outer cylinder is, the outer cylinder is, the outer cylinder is shrunk fit, outer cylinder is shrunk fit over the inner cylinder, over the inner cylinder by heating and cooling, by heating and cooling. By heating and cooling. Full stop. On cooling, on cooling, on cooling, the contact pressure is developed, the contact pressure is developed at the junction of two cylinders, at the junction of two cylinders. At the junction of two cylinders. Full stop. This pressure induces, this pressure induces, this pressure induces compressive tangential stress, compressive tangential stress at outer surface of inner cylinder, at outer surface of inner cylinder and tensile tangential stress at inner surface of outer cylinder. Tensile tangential stress at inner surface of outer cylinder. Now take terminology. Take terminology. Take terminology. First one is DI. DI is DI is inside diameter. DI is inside diameter of inner cylinder inside diameter of inner cylinder and this will become equal to 0 for shaft. Okay, this will be 0 for a shaft. Okay, next is D. Yes. This is outside the diameter of inner cylinder. This is outside dia of inner cylinder. Next, DC. DC is common diameter after shrink fit. DC is common diameter after shrink fit. Common diameter after shrink fit. Common diameter after shrink fit or junction diameter. Okay. PC, next is PC is equal to contact pressure or pressure at contact surface. That is pressure at contact surface. Pressure at contact surface. Okay. So now what you do is take the equation 7.35 to 7.38. Go to cylinders chapter, note down equation 7.35 to 7.38, which will give us 7.38, okay, which will give us tangential stress at inner surface of inner cylinder, tangential stress at outer surface of inner cylinder, then tangential stress at inner surface of outer cylinder and tangential stress at outer surface of outer cylinder. Please note down those equations from your data handbook.
everyone, my name is Ray. Thank you for visiting my channel, and please don't forget to subscribe. Everyone, my name is Ray. Thank you for visiting my channel, and please don't forget to subscribe.
Are you copying?
Yes, sir.
Just ask me later. Okay. Not able to share the video. I don't know how. Yeah, once you have noted down, please let me know. Note down the equations.
Done, sir.
Done, na? Okay. So all of you have noted down the equations. So we'll take up a problem and just type the problem. Please note down the problem. And where, yeah, I'll type the problem. Please note down the problem. Please note down the problem as I am typing. Please note down this problem. D outer, okay. So D outer, D outer is how much? 400 mm. Similarly, common diameter, okay, 2 mm inside diameter is to be shrink fit onto a shaft of diameter 200 mm, okay. So 200 mm is the inside diameter, 400 mm is the outside diameter of the outer diameter of the hub, and it has to shrink fit onto a shaft of diameter 200 mm. So therefore, common diameter is going to be D common diameter, okay, that is DC, okay, is going to be 200 mm, correct? So that is 200 mm. Then what else is given is the maximum to the tangential stress is to be limited to 90 megapascal, okay? So the tangential stress, maximum tangential stress is going to be at common area, that is inside diameter of outer cylinder, okay. Inside diameter of outside cylinder is going to have that is sigma tangential at inside diameter of outer cylinder, that is given by 90 megapascal, okay. So this 90 megapascal, and you are given with the length of hub. Of course, for time being it is not required, and Young's modulus is given as 206 GPa. Poisson's ratio, this we did not, is that mu, whatever that you have in your equation, no, that is Poisson's ratio. Do you have Poisson's ratio in your equation? Is it there?
Yes, sir, 7.36.
Yeah, that's correct. So that mu is the Poisson's ratio. Okay. Find the stresses. That is, we are given with sigma T at inner surface of outer cylinder as 90 megapascal. Use that equation, get the value of the contact pressure, that is pressure at the junction. You find out PC, that you substitute in other equations and get the remaining parameters. Okay, we have got sigma T at inner surface of outer cylinder, that is where the maximum stress is going to occur. So that is given as 90 megapascal. So use that equation sigma T at inner surface of outer cylinder, get the value of PC. That you substitute in other equations and get the values of inner surface of inner cylinder, okay, outer surface of inner cylinder. Then you also find out stress at outer surface of outer cylinder. Calculate it and let me know the values. And DC is 200 mm given in the problem, common diameter. And DI, what is the value of DI? What will be the value of DI?
200.
No, that is common diameter. Inner diameter is for inner cylinder because it's a shaft. So DI is going to be 0.
0, 0.
Yeah. So the equation for sigma T at inner surface of outer cylinder is given by PC of dO square plus DC square divided by dO square minus DC square plus coefficient of friction mu. So when you solve that, the PC value that we get is how much? PC is equal to, please give me this value of PC, contact pressure.
So 54.
54, yeah. 54 Newton per mm square is the contact pressure. Now using this value, you find out sigma T at, that is, we need to find out stress, tangential stress at inner surface of inner cylinder, then tangential stress at outer surface of inner cylinder, and thirdly tangential stress at outer surface of outer cylinder. Calculate these three. Once you find out the value of the contact pressure PC. Give me these values. Use those equations and give me the values of these stresses. Yeah, what is the stress at other different locations?
So minus 180, minus 63 and 60.
Yeah, minus 180, minus 63, no?
Yes, sir.
Yeah, yeah. So that is their compressive stresses, okay? All right. Next is others. Have you found out others needing time? Okay, anyway. So next is radial stresses, okay? So radial stress is nothing but at inner surface of outer cylinder, that is sigma r at inner surface of outer cylinder is equal to minus the contact pressure. Then similarly, radial pressure at outer surface of inner cylinder is also equal to minus PC, and remaining two locations, the radial stress is going to be equal to 0. Is that okay? Are you there?
Yes.
Okay, so please note down that radial stress at inner surface of outer cylinder and radial stress at outer surface of inner cylinder. So both of them are equal to minus contact pressure, minus times contact pressure PC. So when you get time, go to YouTube and check for shrink fit video, okay? Then you will understand what this inner cylinder, outer cylinder, how shrink fitting is done, and what type of stresses that they are going to subjected to, okay? That is, in the other view, so this is, if you take it as inner cylinder, okay? And then this is the outer surface of inner cylinder, and then I'll change the pen. So this is the outermost cylinder, and it will have inner cylinder, inner diameter of outer cylinder will be something like this. Could you get it now? Could you get it now how it will be? So onto the outer diameter of inner cylinder, the inside diameter of outside cylinder will be shrink fit. So because of shrink fitting, there is going to be stresses developed, okay, at the junction. And the diameter at the junction is called the common diameter. And this is the outer diameter, common diameter. This is DC. This is common diameter DC. Okay, that is DC, and this is the outer diameter, okay, outer diameter, and this is the inside diameter of the inner cylinder. So you will have maximum pressure at the contact surface, okay. So that's what and then you will have stresses at inside surface of inner cylinder, then outer surface of inner cylinder, then inner surface of outer cylinder, and outer surface of outer cylinder. These are the four tangential stresses that a compound cylinder is subjected to. Why compound cylinders are made is to withstand very high internal fluid pressures. Is that okay? Could you understand what a compound cylinder is?
Yes, sir.
Fine. Okay. All right, then. I think that's enough for today. Okay, tomorrow 11 o'clock B1 batch you will have